Let us look at proposition number 16 of Works of Archimedes, specifically book 1 of On the Sphere and Cylinder. The proposition says, if an isosceles cone be cut by a plane parallel to the base, the portion of the surface of the cone between the parallel planes is equal to a circle whose radius is a mean proportional between the portion of the side of the cone intercepted by the parallel planes and the line which is equal to the sum of radii of the circles in the parallel planes. So let's understand this. Construct a triangle OAB, where AB is the diameter of the cone. A, B, and let's join AB, OA, and OB. So this is a triangle which is through the axis, because AB is the diameter. Let a plane cut the cone parallel to the plane of the base of the cone. So we have to establish a plane which is parallel to the plane of the base. Here, this plane will cut this cone or intersect with this cone in a circle, and this is how it would look like. Now, DE is the line joining the points of intersection of the triangle with the plane. So here DE is the intersection of this triangle with the plane. Now OFC is the axis of the cone. So axis basically is the perpendicular from O to AB. So let's draw that perpendicular. Let's say this is C and this is F. Now that you have got the idea of the intersection of the plane with the cone, that it is a circle, let me hide it off. Now, what the proposition is saying is that the lateral surface area of the cone between the base of the cone and the plane, that is called the frustum, is equal to a circle whose radius is the square root of AD times AC plus DF. So let's see how we can arrive at that. The lateral surface area of the cone with AB as the base, that is the entire cone, is equal to a circle, say P, with the radius square root of OA times AC. OA times AC. And this we have already seen in a previous proposition. We have proved this. Now, that's not the only cone we have. We also have a cone if we ignore the bottom part. If we only look at the top part of the cone. So lateral surface of the cone with DE as the base is equal to a circle, say Q, with a radius square root of OD times DF. So which means the surface area of the cone between the plane and the base of the cone will be equal to the circle P minus circle Q. Because remember, circle P is the area of the entire cone, lateral surface area of the entire cone. And circle Q is equal to the lateral surface area of the top part of the cone. So if we subtract it, we will get the surface area of the frustum. Remember, radius square of P will be equal to OA times AC. And similarly, the radius square of Q will be OD times DF. So let's look at OA times AC first. OA times AC can be written as OA is AD plus OD times AC. So we have split OA into AD plus OD. And this can be distributed. So we end up with AD times AC plus OD times AC. OA times AC, which is the square of the radius of P, minus OD times GF, which is the square on the radius of Q, will be equal to OA times AC is AD times AC plus OD times AC. So we substituted minus OD times DF. Triangle OAC is similar to triangle ODF. Why? Because DF is parallel to AC. So which means OA is to AC is equal to OD is to DF, which implies OD times AC is equal to OA times DF. So here what did we do? We know that when we have a proportion like this, then the product of the extremes is equal to the product of the means. So OD times AC is equal to DF times OA. OA times AC minus OD times DF is equal to AD times AC. We write it as it is, and we take OD times AC minus OD times DF. But OD times AC is equal to OA times DF minus OD times DF. Here DF is common, so which means we can take it out and write it as OA times AC minus OD times DF is equal to AD times AC plus DF times OA minus OD. OA times AC minus OD times DF is equal to AD times AC plus OA minus OD is what? OA minus OD is equal to AD. So we write it as AD times DF. Now what happens? Again we end up with AD as common. So we can take it out. And our expression becomes OA times AC minus OD times DF is equal to AD times AC plus DF. And we know that the circles are to one another as the squares of their radii. Because till now what we have been working with is the radius squares. So when we say OA times AC, we are not talking of the radius, we are talking of the radius square. So which means P is to Q is equal to radius square of P is to radius square of Q. So that means the radius of the circle equal to the surface area of the frustum is equal to AD times AC plus DF. So the radius square of P minus Q is equal to AD times AC plus DF. So which means the radius of P minus Q is equal to the square root of AD times AC plus DF. So here radius of P minus Q is what we have got. So the lateral surface area of the frustum would be equal to the area of a circle whose radius is this. So that is proposition number 16 of works of Archimedes, specifically book 1 of On the Sphere and Cylinder. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now. Bye.